It may not come as any surprise to you, but humans are intrinsically prone to making errors and mistakes. Things like our mental state, physical limitations, environmental conditions, and our emotions all have direct impact on the outcome of the quality and accuracy of the work we perform. Factors such as fatigue, complacency, and stress are of particular importance in aviation maintenance because of the environments where we work, the hours when most aviation maintenance is performed, and the stress put upon us to perform flawlessly. You may already be aware that human conditions such as these can directly affect you and your work as an aviation maintainer. But did you know that these human conditions are inescapable and that you experience them all at one time or another? These conditions, along with many others, are called human factors. Human factors that go unmanaged have the potential to directly cause unwanted and catastrophic events, worker injuries, wasted time, and accidents. Furthermore, it is universally agreed that a clear majority of maintenance errors involve human factors. In fact, some safety experts believe that 80% of all maintenance errors involve human factors. This course is designed to meet the needs of aviation mechanics by providing a primer or refresher about human factors and how they affect our abilities to perform. The course ends with a reinforcement about the necessity for all AMTs to conscientiously stay within the bounds of policies, procedures, rules, regulations, and best practices, because that is the most effective method of ensuring that we are all taking full advantage of the human factors safety nets. Using the materials presented in this course in conjunction with recommended safety materials, you will gain or be reminded about the hazards, risks, and unacceptable consequences that are associated with human factors as they apply to aviation maintenance. So let's get started. It goes without saying that aviation safety relies heavily on maintenance, and when it is not done correctly, it contributes to a significant portion of aviation accidents and incidents. Some examples of maintenance errors are parts installed incorrectly, missing parts, tools left behind, improper documentation, quality escapes, and necessary checks not being performed. When compared to other aviation safety threats, the errors made by an aviation maintenance technician, AMT, can be more difficult to detect and be dormant or inactive for a long time before they become causal factors. In fact, many maintenance errors are never realized. The truth is that most maintenance errors have a little or no negative effect because of the robust and redundant systems, policies, procedures, regulations, and best practices that exists in aviation maintenance environments. But when maintenance errors do have an effect, their results are usually very dramatic. Aviation maintenance technicians are confronted with a set of human factors unique within aviation. Oftentimes, they are working in the late evening or early morning hours in confined spaces, on high platforms and stands, and in a variety of adverse temperature and humidity conditions. The work can be physically strenuous, yet it also requires attention to detail. To make things worse, aviation maintenance technician training is often extremely minimal and/or left up to the technician. Companies seldom provide their maintainers with regularly scheduled formal maintenance training, except in accordance with minimum regulatory compliance. But minimum training may not be enough to ensure that aviation maintainers have adequate insights and knowledge about the latest maintenance technologies and have the skills needed to do their jobs with the highest level of safety. In addition to manipulative skills and knowledge about aircraft systems and structures, mechanics must also be aware of and be vigilant about the human factors that affect them. So, just what are we talking about when we say human factors? The term human factors has increasingly grown in popularity and importance as the aviation industry has realized and recognized that human error rather than mechanical failure is the common thread associated with the majority of aviation accidents and incidents. Because of the complexity of the term, it is impossible to narrow down the study of human factors to a single course of study. Here's the FAA's Chief Human Factors Scientist, Dr. Bill Johnson, as he and his cohort, Dagmar, introduce the multidisciplinary study of human factors.
A likely place to start this presentation is to define human factors for aviation maintenance. Dagmar, do you recall some definitions from past discussions?
Well, Dr. Bill, the first thing that comes to mind is the application of science and engineering to ensure that people, humans, can work safely and efficiently. Maintenance personnel want to be sure that they perform the job correctly to ensure safe flight. They also want to be sure that they pay attention to their own personal safety.
Are you saying that human factors is about personnel, about people doing the right thing?
Since maintenance personnel are humans, that's the first thing that comes to mind when I think of maintenance human factors. But the topic of human factors includes a lot more than just the worker. For example, the work procedures, the tools, and even the aircraft have to be designed in a way that's matched to the physical and mental capability of the worker.
So, simply stated, human factors programs ensure continuing safety and efficiency by paying attention to issues that affect human performance. I suggest that those issues, to which I just referred, include a broad array of scientific and engineering fields. Can you identify examples?
Absolutely. But my examples have the highest value for this presentation if I put them in plain language.
Plain language. I'm in favor of plain language.
Okay, then. It seems like the definition of human factors is based on whom you ask. It seems to include pieces from a lot of disciplines. There's a lot of psychology involved in human factors. In fact, I took a human factors course from the psychology department in college, but every week a different professor showed up. Someone talked about clinical psychology, like the general mental conditions of humans. She was a psychiatrist, and you know psychiatrists have a lot of medical training. Therefore, she also was able to talk about physical health and the effects of medication, alcohol, and other substances and how they affect performance. Then, an organizational psychology professor talked about such things as communication, teamwork, leadership, and how groups all work together or fail together. He even talked about why some sports coaches have winning teams year after year. He mentioned examples of psychology mixed with marketing. For example, a long while back, they had to figure out what Betty Crocker should look like so the American consumer would like her. They even determined that the person cooking a Betty Crocker cake would feel more satisfied about their baking skills if they had to add an egg to the cake mix. Now, these guys were really getting into the head of the consumer, and they do even more of that today. An educational psychologist talked about how people learn, how they remember, and why they forget. He even said that when you may know how to do something, you still need to use checklists and procedures. Failure to follow the written procedure is a common human error in maintenance. And there were more psychology disciplines. I could go on and on and on.
Yeah, I'm pretty sure that you could. So human factors sounds like a bunch of psychology.
That's what I thought at first. But then halfway through the semester, the engineering professors started to show up. Now, I was fortunate that my university had big psych and engineering departments. Yes, an industrial engineer talked about work design, how to write procedures, how to think about the design of the interface between the worker and displays. And it was all about a very structured way to understand jobs by studying each task and then defining the knowledge, the skills, and the attitude to conduct that particular job safely. He also gave some credit to systems engineering. Then a mechanical engineer talked more about ergonomics. He really talked about physical characteristics of humans and about the design of machines to complement human physical characteristics. He described the term anthropometrics, matching equipment to the size of people's bodies. A safety engineer talked about workplace design, about worker regulations from the Occupational Safety and Health Administration. It was all about not getting hurt at work by working smart in an environment that's designed to be safe. Now, she emphasized that even busy workplaces like the ramps at a big airport, they can be designed to reduce risk. She also said that aviation maintenance personnel, like ramp workers and cabin crews, have an injury rate that is well above the national industrial average.
Okay, Dagmar, so human factors is about engineering, psychology, medicine, and more?
Yep, that is what it is all about. But I want to say one more thing here about the class. It was my favorite part, and I may have learned the most here at the end of this class. We went to a coffee shop and watched how they worked. I pulled the human factors disciplines together by visiting the workplaces. We went to an aircraft factory, and we observed how the work was going on there. Then we went to a school where they designed computer-based training. We went to an airline and looked at how simulators are used to train mechanics and pilots. We even went to an emergency clinic where we saw a lot more than we wanted regarding industrial safety and worker injuries. Worker injuries can really have long-term effects on the quality of life for the individual and for their family. And it's a really large expense for the industry as well, and this topic is important. Now, while all the classroom theory did have high value, I thought the human factors topics really made sense once we actually got to the job sites. I think human factors are better when applied than in theory.
Well, Dagmar, after what you said, I guess I don't have to describe human factors. There's no way I could remember that much detail from any class that I took in college.
Well, at least you remembered me as a student because you were the professor of that class that I just described.
I do recall that you earned a very high grade in that class. Your final paper, as I recall, was on human factors in aviation maintenance.
Human factors encompasses a wide range of challenges that influence people very differently, simply because each individual human possesses different capabilities, strengths, weaknesses, or limitations. Aviation maintenance tasks must always have safety nets that take into consideration the possible consequences that can result from these differences. Depicted here are just a few example human factors that affect aviation maintenance technicians. Some are more serious than others, but when 3 or 4 of them combine, they dramatically increase the probability of an accident or incident with potentially terrible consequences. The study of human factors and how they affect our work and safety goes back several centuries. It is a complex, daunting, and very interesting subject. In order to fully understand human factors and how we can use that information, it is necessary to know where and how we got that information. Here's Dr. Johnson once again as he talks about the evolution of human factors knowledge.
Where did all the attention to human factors really start? Again, that question has multiple answers depending on which human factors discipline you're really talking about. We can go all the way back to Leonardo da Vinci as one of the first to study human factors. That would have been in the late 1600s. He drew the Vitruvian Man with all the anthropometric measures of strength and size. He was trying to decide if a human was strong enough to propel an aircraft. By the way, his drawings are unbelievable, and you should see them if you ever get the opportunity. In the early 1900s, industrial engineers such as Frank and Lillian Gilbreth were trying to reduce human error in medicine. They were using callbacks when communicating in the operating room. Scalpel, scalpel. That same procedure is used with most aviation communications today. At the same time, the Wright brothers were figuring out how to fit a human into the first aircraft. Shortly after that, the U.S. Army was determining the required physical and mental characteristics for flight training candidates. They were also considering human factors as contributing causes to accidents. Jump to the 30s, when a lot of interesting psychology was going on in Europe with the likes of Sigmund Freud and the famous organizational psychologist Kurt Levin. But I should really move to modern human factors, and especially to maintenance human factors history. So on to the 1940s, during World War II, the military in many countries began to notice a lot of training and operational accidents were caused by human error. Those errors were often a result of poor aircraft cockpit layout and non-standardized displays and controls. On the maintenance side, it became obvious that maintenance was neglected because the aircraft design did not give proper attention to maintainability. And you can be sure those old piston engines turning complicated propellers needed a lot of maintenance. That led to efforts to design and build aircraft not only for flying, but also for fixing. The industry has come a long way in design for maintainability. Continuing on this rapid history lesson, the Human Factors and Ergonomics Society was established in 1957, so it has been going on for 50 years now. There are 5,000 members today. I can make another 30-year jump to 1988 when the top blew off on Aloha Airlines 737 over the Pacific. That event drew the attention of North America and the entire world. It caused the FAA to increase focus on the issues of aging aircraft and also on maintenance human factors. By 1989, the FAA, as well as Transport Canada, appointed personnel to dedicate themselves to maintenance human factors. Since then, this type of activity has continued throughout the world.
Due to a large number of maintenance-related aviation accidents and incidents that occurred in the late 1980s and early 1990s, Transport Canada identified 12 human factors that degrade people's ability to perform effectively and safely, which could lead to maintenance errors. These 12 factors, known as the Dirty Dozen, were eventually adopted by the aviation industry as a straightforward means to discuss human error in maintenance. It is important to know the Dirty Dozen, how to recognize their symptoms, and, most importantly, know how to avoid or contain errors they produce. By understanding the interaction between organizational, work group, and individual factors that may lead to errors in accidents, AMTs can learn to prevent or manage them proactively. Each tab on the left represents one of the Dirty Dozen human factors. Click on each tab to learn more about it and what safety nets can be used to protect yourself and your organization. Each tab on the left represents one of the Dirty Dozen human factors. Click on each tab to learn more about it and what safety nets can be used to protect yourself and your organization. Lack of communication is a key human factor that can result in suboptimal, incorrect, or faulty maintenance. Communication occurs between the AMT and many people, such as management, pilots, part suppliers, and aircraft servicers. Each exchange holds the potential for misunderstanding or omission. But communication between AMTs may be the most important of all. Lack of communication between technicians could lead to a maintenance error and result in an aircraft accident. This is especially true during procedures where more than one technician performs the work on the aircraft. It is critical that accurate, complete information be exchanged to ensure that all work is completed without any step being omitted. Knowledge and speculation about a task must be clarified and not confused. Each step of the maintenance procedure must be performed according to approved instructions as though only a single technician did the work. Work should always be done in accordance with the approved written procedure, and all of the performed steps should bear the signature of the technician who accomplishes the work. If necessary, a phone call can be made to obtain an oral turnover when technicians cannot meet face-to-face at the work area. In general, the technician must see his or her role as part of a greater system focused on safe aircraft operation and must communicate well with all in that system to be effective. Complacency is a human factor in aviation maintenance that typically develops over time. As a technician gains knowledge and experience, a sense of self-satisfaction and false confidence may occur. A repetitive task, especially an inspection item, may be overlooked or skipped because the technician has performed the task a number of times without ever finding a fault. The false assumption that inspection of the item is not important may be made. However, even if rare, a fault may exist. The consequences of the fault not being detected and corrected could cause an incident or accident. Routine tasks, performed over and over, allow time for the technician's mind to wander, which may result in a required task not being performed. To combat complacency, a technician must train oneself to find the fault that created the inspection item in the first place. He or she must stay mentally engaged in the task being performed. All inspection items must be treated with equal importance, and it must never be assumed that an item is acceptable when it has not been inspected. A technician should never sign for any work that has not been performed. Prior to the pen touching the paper for a signature, the technician should read the item before signing and confirm it has been performed. A lack of knowledge when performing aircraft maintenance can result in a faulty repair that can have catastrophic results. Differences in technology from aircraft to aircraft and updates to technology and procedures on a single aircraft also make it challenging to have the knowledge required to perform airworthy maintenance. All maintenance must be performed to standards specified in approved instructions. These instructions are based on knowledge gained from lack of communication is a key human factor that can result in suboptimal, incorrect, or faulty maintenance. Communication occurs between the AMT and many people, such as management, pilots, part suppliers, and aircraft servicers. Each exchange holds the potential for misunderstanding or omission. But communication between AMTs may be the most important of all. Lack of communication between technicians could lead to a maintenance error and result in an aircraft accident. This is especially true during procedures where more than one technician performs the work on the aircraft. It is critical that accurate, complete information be exchanged to ensure that all work is completed without any step being omitted. Knowledge and speculation about a task must be clarified and not confused. Each step of the maintenance procedure must be performed according to approved instructions as though only a single technician did the work. Work should always be done in accordance with the approved written procedure, and all of the performed steps should bear the signature of the technician who accomplishes the work. If necessary, a phone call can be made to obtain an oral turnover when technicians cannot meet face-to-face at the work area. In general, the technician must see his or her role as part of a greater system focused on safe aircraft operation and must communicate well with all in that system to be effective. Complacency is a human factor in aviation maintenance that typically develops over time. As a technician gains knowledge and experience, a sense of self-satisfaction and false confidence may occur. A repetitive task, especially an inspection item, may be overlooked or skipped because the technician has performed the task a number of times without ever finding a fault. The false assumption that inspection of the item is not important may be made. However, even if rare, a fault may exist. The consequences of the fault not being detected and corrected could cause an incident or accident. Routine tasks, performed over and over, allow time for the technician's mind to wander, which may result in a required task not being performed. To combat complacency, a technician must train oneself to find the fault that created the inspection item in the first place. He or she must stay mentally engaged in the task being performed. All inspection items must be treated with equal importance, and it must never be assumed that an item is acceptable when it has not been inspected. A technician should never sign for any work that has not been performed. Prior to the pen touching the paper for a signature, the technician should read the item before signing and confirm it has been performed. A lack of knowledge when performing aircraft maintenance can result in a faulty repair that can have catastrophic results. Differences in technology from aircraft to aircraft and updates to technology and procedures on a single aircraft also make it challenging to have the knowledge required to perform airworthy maintenance. All maintenance must be performed to standards specified in approved instructions. These instructions are based on knowledge gained from the engineering and operation of the aircraft equipment. Technicians must be sure to use the latest applicable data and follow each step of the procedure as outlined. They must also be aware that differences exist in the design and maintenance procedures on different aircraft. It is important for technicians to obtain training on different types of aircraft. When in doubt, a technician with experience on the aircraft should be consulted. If one is not available or the consulted technician is not familiar with the procedure, a manufacturer's technical representative should be contacted. It is better to delay a maintenance procedure than to do it incorrectly and cause an accident. A distraction while performing maintenance on an aircraft may disrupt the procedure. When work resumes, it is possible that the technician skips over a detail that needs attention. It is estimated that 15% of maintenance-related errors are caused by distractions. Distractions can be mental or physical in nature. They can occur when the work is located on the aircraft or in the hangar. They can also occur in the psyche of the technician, independent of the work environment. Something as simple as a cell phone call or a new aircraft being pushed into the hangar can disrupt the technician's concentration on the job. Less visible is a difficult family or financial matter or other personal issues that may occupy the technician's thought process as work is performed. This can make the performance of the required maintenance less effective. Regardless of their nature, numerous distractions may occur during the course of maintaining an aircraft. The technician must recognize when attention to the job at hand is being diverted and assure that work continues correctly. A good practice is to go back 3 steps in the work procedure when one is distracted and resume the job from that point. Use of a detailed, step-by-step written procedure and signing off each step only after it is completed also helps. Incomplete work can be marked or tagged, especially when the technician is pulled from the work by a distraction and it is unknown when the work will be resumed and by whom. Disconnect any connector and leave it plainly visible if an installation is not complete. There is a tendency to think a job is finished when a component is hooked up. Similarly, when a step in the maintenance procedure is complete, be sure to immediately lock wire or torque the fasteners if required. This can be used as an indication that all is well up to that point in the procedure. A lack of teamwork may also contribute to errors in aircraft maintenance. Closely related to lack of communication, teamwork is required in aviation maintenance in any instances. Sharing of knowledge between technician, coordinating maintenance function, turning work over from shift to shift, and working with flight personnel to troubleshoot and test aircraft are all executed greater in an atmosphere of teamwork. Often associated with improved safety in the workplace, teamwork involves everyone understanding and agreeing on action to be taken. A gear swing or operational check involves all the members of a team working together. Multiple technicians contribute to the effort to ensure a single outcome. They communicate and look out for one another as they do the job. A consensus is formed that the item is airworthy or not airworthy. The technician primarily deals with the physical aspect of the aircraft and its airworthiness. Others in the organization perform their roles and the entire company functions as a team. Teams can win or lose depending on how well everyone in the organization works together toward a common objective. A lack of teamwork makes all jobs more difficult and, in maintenance, could result in a miscommunication that affects the airworthiness of the aircraft. Fatigue is a major human factor that has contributed to many maintenance errors resulting in accidents. Fatigue can be mental or physical in nature. Emotional fatigue also exists and affects mental and physical performance. A person is said to be fatigued when a reduction or impairment in any of the following occurs: cognitive ability, decision-making, reaction time, coordination, speed, strength, and balance. Fatigue reduces alertness and often reduces a person's ability to focus and hold attention on the task being performed. Suggestions to help mitigate the problems caused by fatigue include looking for symptoms of fatigue in one's self and in others. Have others check your work, even if an inspector sign-off is not required. Avoid complex tasks during the bottom of your circadian rhythm. Sleep and exercise daily. 8 to 9 hours of daily sleep are recommended to avoid fatigue. 14 CFR 121 regulations only require a company to provide a mechanic 24 hours time off during a work week, and there are no regulatory rest limits for general aviation mechanics. Obviously, these regulations are minimal and should never be considered adequate. Therefore, it is up to companies and technicians to regulate shift work and time off to reduce the potential for errors. Most importantly, each technician must monitor and control his or her sleep habits to avoid fatigue. Within an organization, making sure that personnel have the correct tools for the job is just as important as having the proper parts when they are needed. Having the correct tools means not having to improvise. The cost of improvising can be very steep. The right tools to do the job need to be used at all times, and if they are broken, out of calibration, or missing, they need to be repaired, calibrated, or returned as soon as possible. Technical documentation is another critical resource that can lead to problems in aviation maintenance. Resources such as publication departments and manufacturers' technical support are available and should be used rather than ignoring or improvising when problems arise. Organizations should encourage open communication between flight crews and the maintenance crews as a continual resource. When the proper resources are available for the task at hand, there is a much higher probability that maintenance will do a better, more efficient job, and higher likelihood that the job will be done correctly the first time. Organizations must learn to use all of the resources that are available, and if the correct resources are not available, make the necessary arrangements to get them in a timely manner. The end result saves time, money, and enables organizations to complete the task, knowing the aircraft is airworthy. Aviation maintenance tasks require individuals to perform in an environment with constant pressure to do things better and faster without making mistakes and letting things fall through the cracks. Unfortunately, these types of job pressures can affect the capabilities of maintenance workers to get the job done right. Organizations must be aware of the time pressures that are put on aircraft mechanics and help them manage all of the tasks that need to be completed so that all repairs, while done in a timely manner, are completed correctly, with safety being the ultimate goal. Likewise, AMTs need to recognize on their own when time pressures are clouding their judgments and causing them to make unnecessary mistakes. Self-induced pressures are those occasions where one takes ownership of a situation that was not of their doing. In an effort to combat self-induced pressure, technicians should ask for help if they feel overwhelmed and under a time constraint to get a repair fixed. Another method is to have someone check the repair thoroughly to ensure that all maintenance tasks were completed correctly. Finally, if given a repair with a specific time limitation that you do not feel is realistic or compromises safety, bring it to the attention of the organization's management and openly discuss a different course of action. Assertiveness is the ability to express your feelings, opinions, beliefs, and needs in a positive, productive manner and should not be confused with being aggressive. It is important for AMTs to be assertive when it pertains to aviation repair rather than choosing or not being allowed to voice their concerns and opinions. The direct result of not being assertive could ultimately cost people their lives. Lack of assertiveness can be offset by address managers and supervisors directly by stating the problem. Explain what the concern will be, propose possible solutions to the problem, and always solicit feedback and include other opinions. Assertive behavior may not be a skill that comes naturally to every individual, but it is a critical skill to achieve effectiveness. AMTs should give their supervisors and management the kind of feedback required to ensure that they will be able to assist the mechanic to do their job. Aviation maintenance is a stressful task due to many factors. Fast-paced technology that is always changing can add stress to technicians. Stressors include working in dark, tight spaces, lack of resources to get the repairs done correctly, and long hours. The ultimate stress of aviation maintenance is knowing that the work they do, if not done correctly, could result in tragedy. The causes of stress are referred to as stressors. They are categorized as physical, psychological, and physiological stressors. Physical stressors add to the personnel's workload and make it uncomfortable for him or her in their work environment. Psychological stressors relate to emotional factors, such as death or illness in the family, business worries, poor interpersonal relationships with family, co-workers, supervisors, and financial worries. Physiological stressors include fatigue, poor health condition, hunger, and disease. People cope with stress in many different ways. Specialists say that the first step is to identify the stressors and the symptoms that occur after exposure to those stressors. Other recommendations involve development or maintenance of a healthy lifestyle with adequate rest and exercise, a healthy diet, limited consumption of alcohol drinks, and avoidance of tobacco products. Lack of awareness is defined as a failure to recognize all the consequences of an action or a lack of foresight. In aviation maintenance, it is not unusual to perform the same maintenance task repeatedly. After completing the same task multiple times, it is easy for technicians to become less vigilant and develop a lack of awareness for what they are doing and what is around them. Each time a task is completed, it must be treated as if it were the first time. Norms is short for normal, or the way things are normally done. They are unwritten rules that are followed or tolerated by most organizations. Negative norms can detract from the established safety standard and cause an accident to occur. Norms are usually developed to solve problems that have ambiguous solution. When faced with an ambiguous situation, an individual may use another's behavior as a frame of reference around which to form his or her own reactions. As this process continues, group norms develop and stabilize. Norms have been identified as one of the dirty dozen in aviation maintenance, and a great deal of anecdotal evidence points to the use of unsafe norms on the line. The effect of unsafe norms may range from the relatively benign, such as determining accepted meeting times, to the inherently unsafe, such as signing off an incomplete maintenance task. Any behavior commonly accepted by the group, whether as a standard operating procedure, SOP, or not, can be a norm. Supervisors need to ensure that everyone adheres to the same standards and not tolerate unsafe norms. AMTs should pride themselves on following procedure rather than unsafe norms that may have been adopted. As we have learned, there are many concepts, programs, and approaches related to the science and practice of human factors. However, from a practical standpoint, having a memorable and repeatable focal point to help decide what kinds of human factors we should be concerned about would be very useful, and we just happen to have such a tool. For more than a decade, the term PAIR has been used as a memory jogger, or mnemonic, to characterize human factors in aviation maintenance. PAIR prompts recall of the 4 important considerations for human factors programs, which are people who do the job, environment in which they work, actions they perform, and resources necessary to complete the job. Here's Dr. Johnson again to tell us more about the PAIR mnemonic and how it can help us to become more aware of the human factors we experience every day.
A lot of times it's easier to remember something by using a mnemonic. That's an easy-to-recall word where each letter represents.
As we have learned, there are many concepts, programs, and approaches related to the science and practice of human factors. As we have learned, there are many concepts, programs, and approaches related to the science and practice of human factors. However, from a practical standpoint, having a memorable and repeatable focal point to help decide what kinds of human factors we should be concerned about would be very useful, and we just happen to have such a tool. For more than a decade, the term PAIR has been used as a memory jogger, or mnemonic, to characterize human factors in aviation maintenance. PAIR prompts recall of the 4 important considerations for human factors programs, which are people who do the job, environment in which they work, actions they perform, and resources necessary to complete the job. Here's Dr. Johnson again to tell us more about the PAIR mnemonic and how it can help us to become more aware of the human factors we experience every day.
A lot of times it's easier to remember something by using a mnemonic. That's an easy-to-recall word where each letter represents another word. I want to offer you a mnemonic that will help you recall 4 words that capture the most important human factors concepts. I may be guilty of oversimplification, but a lot of people say to keep it simple. Dagmar, what do you think of when I say PAIR?
Well, I think of a greenish yellow fruit that tastes really sweet when you can find one ripe. It seems like they're hard to find in grocery stores.
Right. I think most people would have the same idea and the same complaint about pears in the grocery store. But I suggest that you take the word PAIR and let the letters represent the 4 key things that you would consider in a human factors program. I started to use the PAIR concept with Dr. Mike Maddox in the early 90s. We were trying to be sure that the international client at that time would remember the primary human factors principles once the class was over. We felt that existing models were abstract, they were hard to recall, and not matched to maintenance.
All right, enough history, Dr. Bill. Exactly what does PEAR stand for?
P stands for people. If you're going to address human factors, you have to know about the workers or about the humans that are going to use the products. You must pay attention to the many physical and psychological factors that affect how people are prepared to do their job. Dagmar, can you think of a people issue?
Yeah, I can. I can think of at least 2 categories of people issues, mental and physical. Mental or psychological issues could include attitude, aptitude, knowledge, the amount of training and experience, and the general mental fitness for duty. Now, the physical issues, those can include any such thing as gender, size, strength, vision, physical fitness, and more.
That's an excellent answer. By the way, some call the study of physical human factors ergonomics, but it's generally okay to interchange the terms. However, the term human factors is more widely used. The next one is E for environment.
Now that one is easy. Hot, cold, wet, dry, light, dark. Now those are environmental issues.
Well, you're 50% correct on that one. You described the physical environment. That's the easy one to address with proper clothing, with heating, ventilation, and cooling systems, or by adding proper lighting for the task. The other environment is called the socio-technical environment. Now, that's a fancy term for issues like management, labor cooperation, establishment of a safety culture, company profitability, job security, and more. Of course, this environment is tougher to measure and to maintain than the physical environment. However, they're both important. So the next letter in PAIR is A, which stands for actions. What are we talking about there?
I guess that means to look at the specific actions that people do at work, like the objectives of the job. What are the many tasks that are necessary to complete the job? Are the tasks completed, are they one at a time, or can many go on in parallel? I mean, there must be at least 1 million things to consider in each action.
Yeah, that million estimate, it's a good one. It's an interesting number. Once you identify the actions and break them into tasks, then you define the skills, the number of people needed, the types of equipment and tools, and the performance standard to determine what's the acceptable quality and safety. So actions is yet another important part of human factors planning. The last letter is R for resources. What do we think we mean by that one?
All right, let's see. The P stands for people. The E is for the environment where the people work, and A stands for the actions that they perform. So the resources would include having and using technical manuals, tools, other coworkers, enough time to complete the job, and enough training, on and on and on. I mean, I guess it would even include the company's ability to pay a fair wage with good benefits and to retain a qualified and happy workforce.
Another excellent answer. As you start listing resources, it's hard to avoid talking about the other letters in PAIR. It all ties together, and that's why PAIR is an excellent way to think and talk about human factors issues.
The P in the PAIR model represents people, which is a very complex part of the safety equation. One of the most common human factors that all humans experience is human error. Human error is defined as a human action with unintended consequences. Most human errors are accompanied by little or no consequences. In fact, there is nothing inherently wrong or troublesome with human error itself because it is part of being human. But when human error is coupled with aviation maintenance, the unwanted consequences can be very large. The problem with human error is that no one can escape making mistakes, having memory lapses or slips. Human errors are a part of being human. The bad news is that unintentional human error is not avoidable. The good news is that human error is manageable if it is recognized as a human factor and policies, procedures, regulations, and best practices are in place to limit the unwanted consequences. Training, risk assessment, safety inspections, checklists, company policies, manufacturer procedures, regulations, and best practices are all safety nets designed to help balance the potentially bad things that can happen when unintentional human errors occur. Let's watch as Dr. Johnson and Dagmar discuss the maintenance error concept.
To err is human. To forgive is divine. The English poet Alexander Pope said that over 300 years ago, but it still applies to maintenance error today. Let's introduce a few error concepts and ways to control error. It involves erring and forgiving. So Dagmar, what is error?
Well, you make a mistake, You slip up, you take an action that has an unplanned or an unintended result.
Do you do it on purpose?
Well, now, if you did it on purpose, it wouldn't be an error. It would be an intentional disregard for the proper way to conduct a task. I believe the FAA calls that a violation. For example, yesterday, I reached into my purse for my mobile phone. I pulled it from my purse. I dropped it into the parking lot. That was an error. One result is that I now have this cool new mobile phone, but that was not my intention.
So were there factors that contributed to that error? Did you identify and correct those factors? Will it happen again?
Yes, and no. It probably won't happen again. Now, at first, I did want to blame anyone but me. However, after I thought about it, there were multiple factors that contributed to my error. I was in a hurry. My mind was on something else entirely. I tried to grab the phone while getting out of the car. The list just goes on and on and on. I made a mistake, an error.
Well, then would you forgive yourself for breaking the phone and having to buy a new one?
Yeah, I'll forgive myself, but I will be more careful the next time around. And I also cleaned out some of that junk out of my purse. So when I selected the new phone, I also found one that fit my hands better. And I bought that extra policy that repairs or replaces the phone just in case it's dropped again. Finally, I reminded myself to slow down, and I'm sure I'll be getting a better grip on this nice new phone.
You know, everything about your mobile phone story applies to maintenance error and also to forgiving maintenance error. Mechanics' activities are often clearly defined by written task procedures. The most common cause of an event in a maintenance error is when a mechanic deviates from the procedure for whatever reason. Usually it's an innocent error, an unintended mistake. Intentional disregard of a written procedure is treated more seriously because it was intentional. FAA and industry are working together on programs where mechanics can admit when they made an honest mistake. These programs ensure that the mechanic will not be punished by the company or by the FAA. The Boeing company created a process for industry to investigate the error, to find the contributing factors, and to ensure that the mistake is not likely to occur again. It's the same thing you did with your mobile phone, but perhaps more investigation process oriented.
Here are two types of human error that aviation mechanics must be aware of. First, the unintentional error. An unintentional error is an unintentional wandering or deviation from accuracy. This can include an error in your action, a slip, opinion, or judgment caused by poor reasoning, carelessness, a lapse, or insufficient knowledge, a mistake. For example, if an AMT reads the torque values from a job card and unintentionally transposed the number 26 to 62, it is an unintentional error. He or she did not mean to make that error, but knowingly and unintentionally did. Another example of an unintentional mistake would be selecting the wrong work card to conduct a specific repair or task. Again, not an intentional mistake, but a mistake nonetheless. As you can see, these examples of unintentional errors may or may not have serious consequences. Now the intentional error. When someone knowingly or intentionally chooses to ignore established policies and or procedures, it is not only an intentional error, it is a violation. Intentional errors are considered violations because they totally circumvent established policies, procedures, regulations, and best practices that were carefully crafted and designed to minimize the negative consequences when unintentional human errors occur. Here are a few reasons why violation errors are so dangerous. 1. People who violate usually don't consider whether or not their violation will combine with the violations of others. Violators typically presume that everyone else is following all rules and procedures. The mechanic who makes a violation generally feels that he or she is the only one committing a violation. This would be natural since individuals who violate seldom publicize that they have done so. If there is another mechanic who has secretly committed a violation, the potential for negative consequences is multiplied. 2. Before actually making the decision to commit a violation, A mechanic typically does an on-the-fly risk analysis about the dangers associated with its commission. Because it is rare that a violator will have all of the history, data, and information concerning any given risk, it is improbable that a fully informed risk assessment will be made prior to the decision to do the violation. Furthermore, a risk analysis without a complete set of information is commonly contaminated with rationalizations that support the violation decision. 3. After the violation has been commissioned, the violating mechanic is not likely to announce, record, or admit that the violation occurred. Mechanics are many things, but we are no fools. This makes it impossible for controls, mitigations, and safety nets to be effective. 4. Statistically, the work performed by a person who violates is 10 times more likely to be involved in an accident or incident. Worse yet, if that work does become involved in an occurrence, it is 4 times more likely to involve a fatality. Bottom line is that safety nets like policies, procedures, rules, regulations, and best practices are all meant to discover human errors and to minimize their negative consequences, and violations negate or circumvent those safety nets. According to Dr. James Reasons and Dr. Alan Hobbs in their book Managing Maintenance Error, Death, Doom, and Disaster is directly related to the combination of violations with human error.
What would you do? It's the end of the night shift, and Joe, the night shift manager, has just discovered that the right overwing fuel cap on one of the turboprops is leaking. He is concerned that the O-rings of the fuel cap are deteriorated. He asks Bill, the lead mechanic, to stop what he's doing to go check on the fuel leak situation. Bill is extra tired because he came in early to cover for another mechanic. Since he hadn't planned to work the extra hours, he had gone to his son's soccer game earlier in the day instead of getting his normal daytime sleep. It's dark out on the ramp, and it's raining. Bill knows that the only ladder the company owns has been broken for the past 18 months, and that Joe doesn't have an extra person to assign as a spotter while he's up on the ladder. Bill wants to tell Joe to ask someone else, but knows that Joe is under pressure to be sure that all the aircraft are ready before the pilots arrive in just a few hours. This scenario is not uncommon in maintenance. Names and circumstances change, but the human factors involved probably triggered some of your own memories about similar experiences. Click on each of these tabs to learn about which response you might or might not choose. Try to identify some dirty dozen human factors involved. Think about the safety nets in play. Which ones are working and which ones are being ignored? After you've studied each of the choices, reflect on some of your own potentially unsafe experiences. And based on insights learned from Joe's experience, what would you do if you came up against those conditions again? Cap? You wouldn't really, would you? This would be an unacceptable choice. Check the other choices. Get the job done. You decide to go find the ladder, grab a flashlight, and go out in the rain to check the O-rings on the fuel caps. When you find the ladder, you're quickly reminded by its condition that it isn't exactly the safest ladder in the world. All of the mechanics in the shop have known the ladder is broken, but everyone seems to just keep using it anyway. There is a company rule against using defective equipment, but since everyone is using the ladder, why not one more time? Scuttlebutt in the hangar is that the company's having financial problems, and that's why the ladder hasn't been replaced. You remind yourself that it's only the third rung on the ladder that's unsafe. You decide it'll be okay. Besides, the company needs the airplane in the morning, and you aren't going to let the flight crew take an airplane with leaking fuel caps. Yeah, that's what Joe's safety rationalizations were too. He took the ladder out on the dark and rainy flight line with his flashlight, and while he was standing on the third rung of the ladder, holding the flashlight in one hand and reaching for the fuel cap with the other hand, lost his balance and ended up falling. Doctor said he has some bruised ribs and should stay home from work for at least 3 days. Based on Joe's experience, this might not be the safest choice. Check out other choices. Just say no. You review the situation. You're tired. It's raining and the ramp is wet. The only ladder is broken. It's dark and the shop is short-handed. You know the company has a rule against using defective equipment, and this ladder is definitely defective. You decide to tell Joe that the circumstances just aren't safe enough for you to take the assignment. You recommend that Joe borrow a ladder from the aircraft fuelers across the ramp and wait until daybreak to do the fuel cap check. It might mean a 10-minute delay getting that aircraft into service in the morning, but the safety margins will be much more in everyone's favor. This would be the safest choice.
In this case, an AMT climbs a ladder to do a repair, knowing that the ladder is broken and falls off, resulting in bruised ribs and having to take several days off from work. On the immediate surface, simple investigation would summarize that the latent error was the broken ladder that the company should have replaced 18 months ago. Further investigation might suggest that the latent human error is even more egregious. The broken ladder had been used successfully by all of the shop mechanics for the past 18 months. Each mechanic was aware that the ladder was broken, but continued to use it, regardless that the company's safety policy prohibited the use of defective equipment. Both the company and mechanics had rationalized that using the defective ladder was acceptable. The company thought it was not necessary to replace the ladder because the mechanics knew the company's "don't use defective equipment" rule. So the company rationalized that the mechanics must have thought it was not broken enough and it was safe to use. At the same time, the mechanics rationalized that the company didn't replace the ladder because there was a financial shortfall. Mechanics are wonderful human beings, and it isn't uncommon for them to do whatever it takes to ensure the success of the organization, like putting him or herself in danger of falling off a defective ladder. In this story, lack of communication, complacency, lack of assertiveness from the mechanics to tell the company, lack of team support or assertiveness among the mechanics to discourage using the ladder, or pressures to get the job done with minimal work interruption might all have been contributing human factors. It could easily be seen that the mechanics were complacent about safety rules and felt they could safely work around the defect. Inappropriate norms, or possibly even peer pressure to use the broken ladder were definitely human factors in play. It's possible to imagine a myriad of scenarios that lead up to the mechanic falling, and any or all of them could be correct. But you'll miss the whole point if you stop your analysis here. The point is that there was one safety net in place that could have absolutely prevented this mechanic from being injured. But that safety net was intentionally disregarded. It was against company policy for mechanics to use defective equipment. Clearly, if the ladder had been replaced or repaired 18 months ago in accordance with company policy, or if the mechanic had complied with company policy not to use defective equipment, then the perfect storm of human factors that encouraged the mechanic to rationalize that it would be all right to use the defective ladder one more time would have been completely eliminated. But wait, there's still more. All we've done so far is found out that the culprit who fell was not following policy and that the company should have replaced the ladder 18 months ago. But finger-pointing is not likely to keep these circumstances from reoccurring. The latent active violation that occurred in this story is perhaps only a symptom of a much greater causal factor. Maybe the real root cause of this incident was that there existed an organizational safety culture that allowed, maybe even encouraged, this risky behavior. Had the safety culture of the maintenance organization been one that totally discouraged any non-compliant behavior of any kind, there would never have been the opportunity for unmanaged human factors to combine and cause the mechanic to get hurt. There was a policy in place that mitigated the human factors in play, but the culture of the organization did not believe in or respect the one safety net that could have saved the day. No doubt, today this company has the best and safest ladders for their mechanics to use. But the real question is, did the culture change so that everyone in the organization will no longer accept any kind of violation behavior? What do you think? There are a number of human factors information resources within the FAA. The most direct link for aviation maintenance human factors is the FAA Human Factors website at https://hfskyWay.faa.gov. It offers document access and services, including most of the FAA Maintenance Human Factors documents dating back to the 1988 start of FAA's Maintenance Factors Research and Development Program. New documents include videos, PowerPoint presentations, and other media. The FAA sponsors a multidisciplinary work group that includes subject matter experts from industry, labor research, and government. The focus of the group has been to investigate the issues associated with maintenance fatigue and the practical science-based methods that can be used to manage fatigue risk. This site offers fatigue risk management tools and information that are not available anywhere else. There is a free fatigue countermeasures training course for aviation maintainers. The fatigue awareness video, Grounded, is one of the best action-packed videos ever produced about aviation maintenance fatigue and is available for you to watch, download, and share with your colleagues. Managers who are interested in the cost benefits associated with a well-established fatigue reduction program can use the return on investment calculator here. This site has a whole host of portals that will take you to things such as frequently requested tools, a fatigue management toolbox, current news and events, educational materials about maintenance fatigue, regulations, publications, and links outside of the FAA that are good resources for fatigue risk management. For access to the FAA's maintenance fatigue website, go to www.mxfatigue.com. For access to the FAA's FAST Team website, go to www.faasafety.gov. The FAA's Safety Team's dedicated website provides up-to-date information about safety concerns, upcoming seminars, featured courses, and resources. There is a portal here just for aircraft maintainers, the Maintenance Hangar. As free aviation safety courses are added to our already large course library, we will announce them in the Featured Courses portal. There are thousands of FAA safety seminars given around the nation, and you can easily find the one nearest you by clicking into the upcoming seminars portal. Of course, as a maintenance technician, your participation in the FAA On-Line AMT Awards program is very important to both you and your employer. This portal gives you quick access to that program. If you aren't already registered, take a few minutes to create your own account at our FAAsafety.gov website. Well, that's a lot about aviation human factors, what it is, where it came from, how no one is exempt from their effects and effects, and how quickly and seriously they influence the outcome of aviation safety. As we bring this course to a close, think about how all this human factors information might make a difference when you begin your next aircraft maintenance task. What will you do different? What will you see differently? What will you personally do to help increase safety margins? One of the ways you can make an instantaneous difference is to use the Maintenance Personal Minimums Checklist. This is a free detailed list of items that will ensure everything has been performed in the safest manner possible before and after the task. Your local FAST Team program manager can provide your company with the PowerPoint, a video, and instructions about how to use the Personal Minimums Checklist. Copies of the checklist are available in 3 sizes to put in your toolboxes, hang on the wall in the hangar, and carry. Well, that's a lot about aviation human factors, what it is, where it came from, how no one is exempt from their effects and effects, and how quickly and seriously they influence the outcome of aviation safety. As we bring this course to a close, think about how all this human factors information might make a difference when you begin your next aircraft maintenance task. What will you do different? What will you see differently? What will you personally do to help increase safety margins? One of the ways you can make an instantaneous difference is to use the Maintenance Personal Minimums Checklist. This is a free detailed list of items that will ensure everything has been performed in the safest manner possible before and after the task. Your local FAST Team program manager can provide your company with the PowerPoint, a video, and instructions about how to use the Personal Minimums Checklist. Copies of the checklist are available in 3 sizes to put in your toolboxes, hang on the wall in the hangar, and carry with you in your pocket. Now, here's Dr. Johnson and Dagmar to give you some final suggestions about one more way to help bring your human factors knowledge into focus and into action.
Dagmar, we've been saying that we try to use concrete examples when we talk about human factors, but I want to take a chance with a bit of abstraction. I want you and the audience to put on these human factors spectacles.
All right, well, they don't look abstract. I mean, they just look like an ordinary pair of glasses.
Well, they look like plain old glasses, but for now, let's consider them to be special human factors spectacles. Now, don't try them on yet. Wait. I want to ask you a few questions before you put on the spectacles.
Questions? Is this a test? An FAA test?
Well, no, not exactly. What do you see when you look out at the audience?
I guess I see an audience of men, women, people here to listen to a lecture on human factors, and they're watching this video segment.
Well, that's a reasonable vision. But now, try on the human factors spectacles. And when you put on these spectacles, you'll see a lot more, at least I hope so. What do you see now?
I do. I see a lot more. I'm wondering now about the age of the audience. Are they motivated enough to hear our message? Is this screen large enough for them to see me? Is the audio loud enough for them to project to aviation maintenance workers who may have hearing loss from a lot of years around airplane engines? I'm wondering if the chairs that they're sitting on are comfortable enough and when they've had their last break. I'm also starting to wonder if they've had a good night's rest so that they can pay attention and remember what we're talking about. I'm even starting to wonder about it.
Okay, Dagmar, I think the spectacles are working as you look at the audience. That's great. But now, try looking at something else. Look in this mirror with the spectacles. What do you see?
Well, I have to see if I look good, but I'm looking at myself and I'm asking, am I sitting straight and delivering a clear message to the audience? Does my tone indicate enthusiasm? Do I act as if I'm confident with the material that I'm presenting? Am I projecting to those in the back row? So With these human factor spectacles, you look at others, their environment, and what they're doing, and how you can provide the resources necessary to help them accomplish their goals and mine. These spectacles make me look at myself as well. This is not abstract at all.
Well, all this talk about abstraction certainly got your attention. I just hope that we communicated to the audience that anyone can use the human factor spectacles to see a lot of interesting things while at work, while driving, while at home, and in the mirror. Of course, you really don't need the spectacles to look at human factors. Just open your eyes.
When you put on your human factor spectacles at work, you're going to see lots of latent human errors and potential for active human errors that you never saw before. At least you're going to take a new look at what you already know about aviation maintenance safety where you work. As Dr. Johnson stated, one of the most common errors is deviating from well-established company policies, manufacturers' maintenance procedures, established best practices, or published regulations, the violation error. Here are 4 ways you and your fellow mechanics can make immediate safety improvements where you work. 1. Use human factor spectacles to look for unsafe conditions and risky behaviors. 2. Be the example to your colleagues. Always follow policies and procedures. 3. Support your colleagues to always follow policies and procedures. 4. Always report your discoveries. Finally, zero tolerance of procedure and rule violations is and always has been the standard. Whenever we encounter a time to choose violate or not, we must stay committed to this standard. It's the only way to keep our industry safe. If procedures and rules are not workable, speak out. Get them changed. Speak out when deviations and violations become the way we do business. Challenge assumptions. Be the person known for unreasonable integrity. See how long you can go without experiencing a violation error. Here's hoping that you can go a very long time because safety begins with 0 violations.